9.5s on the binomial theorem, and this is all about finding the coefficients of a binomial expansion. For example, here's our binomial x plus y to the 0 power, that's just equal to 1. X plus y to the 1 power, first power, is just x plus y. And look at the coefficients of x and y is a 1x and a 1y. Next one, x plus y squared. Looking at the coefficients, we have a 1x squared, we have 2 times xy, and then a 1y squared, so on and so forth. On cubes, so we have a 1, we have a 3, 3, and a 1. And so this follows Pascal's triangle, which is this here. So what this refers to, so this is the x plus y to the 0 power, and this is just x plus y, and this is x plus y squared, which gives x squared plus 2xy plus y squared. So these are the coefficients that Pascal's triangle shows. So this is the next one down, is to the cubed, x plus y cubed. And so right here we see the coefficients 1, 3, 3, 1. And so we can just build this triangle. Now, here's how we do it. All of the outside numbers are going to be 1. The first number, this 4, means that this is to the 4th power. And so you notice that going down this row here, it just increases by 1. So we could go 1, 5, and we could go then 1, 6. And on the other side, it does the same thing. So all of these are going to be 1s. And going down this diagonal, it just increases by 1. So 1, 2, 3, 4, 5, 6, and so on. So now how do we fill the middle ones? Well, 3 and 3 is 6. And then the 4 and the 6 is 10. And again, 6 and 4 is 10. And so on the 6th power, we had 5 and 10 is 15. 10 and 10 is 20. 10 and 5, 15, and so on and so forth. So using Pascal's triangle for any binomial expansion gives us the coefficients that we need. So the theorem, binomial theorem, x plus y to the n, is given right here. So we have x to the n plus n, x to the n minus 1, y, plus, plus, plus. And here we have this term NCR, which is finding combinations, NCR, which is defined right here. NCR is equal to n factorial divided by n minus r factorial times r factorial. What this means, this is a combination of n elements taken r at a time. So let's look at a couple of examples of NCR. So the first one, 9C2, and this is the way it's commonly written. Sometimes you'll see it little 9 and then a C and a little 2, but a lot of times you just see it written like that. And this is the way your calculator will show it. So what does this mean? This means n factorial, so it means 9 factorial divided by 9 minus 2 is 7 factorial divided by r factorial, which is 2 factorial. So you can do this longhand, 9 times 8 times 7 times 6 times 5 times 4 to 1, and then divided by 7 times 6 times 5, so on and so forth. Or you can just put it in your calculator, and you get 36. Let's look at 11C4, and this means a combination of 11 elements or 11 things taken 4 at a time. How many combinations are you going to have? Well, again, this is 11 factorial over 11 minus 4, which is 7 factorial times 4 factorial. Put it in the calculator, you get 330. And the last one we'll look at, 5c5, is just 5 factorial divided by 5 minus 5, which is 0 factorial, and times 5 factorial. And you remember that 0 factorial is defined as 1. So this is just 5 factorial divided by 5 factorial, which is just 1. Okay, let's look at some examples of expanding binomials. So our first example is x plus 2 to the 4th power. And so what you might want to do at first is write down the coefficients for 4th power. So it's going to be 1, 4, 6, 4, 6. Oh, last one is 1, sorry. 1, 4, 6, 4, 1. And so we can just write out the answer. So we have x to the 4th plus the coefficient 4x cubed, because the powers of x are going to go down and the powers of the y value, which is 2 in this case, are going to go up. So just multiply that by 2 plus 6 x squared 2 squared plus 4x times 2 cubed plus 2 to the 4th. Then you just simplify that. We have x to the 4th plus 8x cubed plus 24x squared plus 32x plus 16. So there's your answer of x plus 2 to the 4th power. Okay, the next example, 2x minus 3y to the 4th. So we're going to have the same coefficients as the previous example, but because we have a negative sign, 2x minus 3y, we're going to have alternating signs. So they're going to be plus, minus, plus, minus, plus. And so also you notice that if we have an x to the 4th, we're going to have 5 terms. If we have x to the 7th, we'll have 8 terms. So let's just start this expansion. So we have 2x to the 4th minus coefficient of 4. We have 2x cubed times 3y. Then plus, our coefficient is 6. We have a 2x squared, 3y squared. And then we have a minus, coefficient is 4 times 2x times 3y cubed, then plus, coefficient is 1, so it's just 3y to the 4th. All right, then we simplify that. So that's going to be 16x to the 4th minus 96x cubed y plus 216 x squared y squared minus 72x y cubed plus 81y to the 4th. So there we go. Okay, the last example, we're going to be finding the nth term of a binomial expansion. So here's our example. Finding the 5th term of a plus 2b to the 8th power. Well, if we look back at our binomial theorem, this is going to be NCR, x to the n minus r, y to the r. And that's going to give our r plus 1 term, r plus 1 term. And so we want to use r. We want to find the 5th term, so we're going to use 5 minus 1, or 4 for the r. The n is 8th power, so here's our n. And in this case, the a is going to be the x, and the y is going to be the 2b. So we can fill this in. So what we're going to have is a 8C4 x to the 8 minus 4 y to the 4th. And so the first thing we're going to do is calculate an 8C4. 8C4 is 70. This is equal to 70. So we have 70 x to the 8 minus 4, which is just 4, and y to the 4th. But we know here's our x is a, and our y is 2b, so this gives us 70a to the 4th, and then we have 2b to the 4th. So this is going to be 70a to the 4th. 2 to the 4th is 16b to the 4th. Multiplying the 70 times the 16, we get 1120 a to the 4th, b to the 4th. So 1120 is the coefficient, then a to the 4th, b to the 4th is the 8th, no, it's the 5th term in this expansion here.